because we are talking about an all-in-one transformer and interface protection, formerly known as secondary protection. Can you walk me through it? Because the first thing I look in here, apart from the, we're still working on it, we've got a bit of stuff there, but that's, is, hang on, where are the inverter circuit breakers?
There aren't inverter circuit breakers in here.
And we'll cover that later. All right, we'll cover what's in there. So straight away, I can see they got some insulation in here, which is interesting because they didn't have insulation on the other side, but there's more componentry in here.
More components in here.
And they've got the same kind of filtration system. Notice that the doors are all earthed. Now, maybe we start from the top and work down. We've got this particular component here, the DRS. Can you explain what that is?
That is a 24-volt power supply that will also operate as a UPS. So those batteries we spoke about earlier, they are connected to that. So if we lose the grid, AC power, that'll switch to UPS mode and continue to supply our 24-volt distribution section, which is just below.
Interesting. Do you know what the capacity of the batteries are?
I cannot remember.
Yeah. So obviously they'd be sized sufficiently to run this for X amount of time. Obviously UPS is there purely for when there's a break in power. It is not like a tariff optimization where you're talking about a best scenario or anything like that. It's simply there, fully charged, waiting to be put into action.
Yep.
Hopefully never.
Hopefully never.
Hopefully never.
But if it does go down and the grid is lost, we would be able to still see the system is active, but we would then see that there is an absence of grid alarm.
Excellent. Now, moving from left to right, you've got the AC main switch, and you've got, you've got the 24 volt DC main control. Can you just...
Yep, so the power from this power supply is fed to this circuit breaker, so you've got a point of isolation at any time for the below 24 volt distribution. So that's all, that's just offering protection to that system. We have several 24 volt components in here. To the right here, we've got the 230 volt distribution section, which takes our 3-phase, and we've got a few loads coming off that for controls specifically of the main breaker, grid protection, charging the batteries.
Yep. And you've got here your 24 volt DC control distribution. You've got your CT test links. So these, so I haven't been on site when they've done secondary injection testing. When they come to do secondary injection testing on the site, where are they putting their probes in?
Right, so pretty much they will disconnect this breaker and they'll connect in most likely at the bottom of this one.
Right. To
supply voltage back to our mains probe.
Yep. So this is the brains. This is the relay, and this is basically, it used to be called secondary protection because it effectively replicates the primary protection within inverters, but it's Plan B. Since the 4777.1 2004 edition, we don't call this secondary protection, we call it interface protection. You've got the main switchboard behind and you've got the transformer on that side. And we're just going through the components here. Now that you've got the SEM CT test links there. So how many CTs would be involved with this particular project?
Well, this particular project has 3 CTs for this meter, which is our LGC meter.
Yep, the EDMI, yep.
3 CTs for this meter,
yep,
which is the SEM or Sungrow energy meter.
Yep.
And then there is a further 3 CTs that need to be installed for the generator meter monitor.
And are these CTs all sized the same, or are we talking about?
These 2 are.
Yep. Right.
I'm unsure as to what the other ones will be.
Right.
Generally speaking, billing CTs are quite hefty. They're about this big each.
Yeah, right. So they don't use those, and correct me if I pronounce it wrong, Rogalski coil kind of stuff.
They do not. Those are a split core CT.
Right.
They use solid core.
Right.
Because the accuracy between a split core and a solid core isn't that much different, but when you're talking about billing, it's significant.
They have to be very, very accurate because at the end of the day, it's all financial, isn't it? Now, this is a Sungrow logger, 1000 amp. So what it's logging?
1000A. So this is a logger 1000A.
Oh. We'll do that bit again.
You put 1,000 amps through this, it's gonna be smoking.
Actually, we won't do this again. That's a mistake I made. So this is a 10,000 amp logger. I'm joking. So this is the Sungrow data logger, and its main purpose is obviously to log the inverters. We can keep this in, it's fine. To log the inverters. So what is it actually recording? So how often is it recording? Where's it all going?
It records if you're connected. It records frequently. So throughout the day, it'll record constantly. This actually controls all the inverters. So this here has two RS485 connections to it at the moment. Yep. One of those connects to our meter, so that this logger can understand how much power is going through our connection.
Right.
In certain circumstances, you could use this setup to limit your export. We're not using that for this situation here. We're using it to be able to monitor what's going through our mains connection. This device here is daisy chained using that same RS485 to all 9 inverters, and that's our main point of connection to our monitoring platform on the internet.
Interesting. And I notice here there's a little bit of a SIM card here.
This particular model has an inbuilt 4G modem.
Wow.
So we're able to insert the SIM at the bottom here, and we don't need to have an extra modem on site.
See, this is the thing, isn't it, Alex? We've talked about this before, like on our last chat, we were at a BESS site, and it's all about, like, the electrician is not just about electricity nowadays. It's all about, if you're doing renewable, you got to know comms, you got to know RS485, RS232, you got to know data communication, this, that, and the other, as well as all the electrical stuff. And you got to know how to bloody commission the system. And if there's a BESS involved, you have to know how to bring it all together.
There is a little bit involved.
That's an understatement. But you are the master of the understatement. Now, right at the bottom here, I notice there's no signage going on yet. There's nothing. What are we talking about in here?
This one will not have signage because these test links X2, X6, X7 and X8, they are depicted in our wiring diagrams for this board. These are only going to be for people who need to wire into it. So specifically, these cables here are connected back to the high voltage RMU, which is over in the distance. So that's where our communications for the oil temperature, oil pressure is going to be sent back out from this board. Yeah, typically when you see a connection block like this at the bottom of the board, it is for connecting external equipment. So it gives you all the terminal points for your different equipment above at a readily accessible location for testing and connection to any devices.
Now, so here we've got this cabling here is from the battery, and
so we have one cable here that's from the battery.
Yep.
We have this one here is an Interlink that will be used for the generator meter monitor to be able to turn off the system.
Right.
And that connects back to our mains pro. And then we have the RS485 cables going out to daisy chain through the system.
Wow, there's a lot to it. Now the antenna, obviously that's
the 4G antenna for this.
Right. Okay. Yep. And the Sungrow, we're fairly familiar with Sungrow, and I suppose most renewable energy companies who have dealt with larger systems, the Sungrow seems to be quite a standard kind of product that's used. And why do you think that is? Is it the ease of design with it? Are they pretty good technical?
They do have a few good things going for them. Their product isn't overpriced. It tends to work without question. And they're pretty straightforward. So when you go to install them, you're not trying to dig through the information to get it running.
Yeah, right.
And they do come with a lot of expandable options, such as the logger.
Wow.
Which makes integrating into larger systems quite easy.
And that's the thing I notice in my experience, people will be very loyal to certain products, like from an inverter perspective, but when it comes to panels, as long as they're tier 1 and at the right price, hey, who cares? The panel's a panel. But inverters and this kind of stuff, it's different.
That is because you don't interface with the panel.
That's it.
You interface with the inverter, and from a customer point of view, once you hand the system over, it's quite easy for them to read it as well.
Yeah, no, that's great.